A very good morning to my respectful lecturer in Chase Arizan bin Muhammad Razali. My name is Kadirvel Armugam, metric card number 17DP19F1069, and my group member's name is Praveen Raj Analalaki Ravi. Metric card number is 17DP19F1070, and then Praveen Analalaki Velu 17DP19F1010. Today we're gonna explain about application and uses of Waveguide.
Okay, we start with the introduction. Okay, waveguide is an instrument or material which can be used to guide waves along a defined path. By doing this, waveguides facilitate wave propagation from a source to another defined point without any loss in wave intensity. Actually, in easy way, we can know that waveguide is an instrument to guide a wave to a point to another point. That's all. It's easier way. Okay, then the application of waveguide is the basic things in the application is optical fiber communication, photonic integrated circuits, maintaining high optical intensities in non-linear devices as mode clearness, and the last one is optical interferometers.
Okay, now I'm gonna explain about the waveguide, type of the waveguide, and then application of the waveguide. There are 5 types of waveguide, which is rectangular waveguide, circular waveguide, elliptical waveguide, double-ridged waveguide, and single-ridged waveguide. First, I'm gonna explain about rectangular waveguide. A rectangular waveguide is a hollow metallic tube with a rectangular cross-section. The conducting wall of the waveguide confine the electromagnetic field and thereby guide the electromagnetic wave. The rectangular waveguide is basically characterized by its dimension, length, and breadth too. Now we move on to the application of rectangular waveguide. First, these rectangular waveguide are widely employed in single transmission device such as radar, coupler, isolator, and attenuator. Electromagnetic wave, just now I say about the electromagnetic wave, are reflected from the conducting wall as they travel longitudinally through a rectangular waveguide. In the propagation direction, total reflection inside the rectangular waveguide result is either an electric and magnetic field component. The rectangular waveguide, there is no TEM mode in a hollow rectangular waveguide with only one conductor. The modes of propagation are either TE or TM. Move on to next is circular waveguide. Circular waveguide, it's same like rectangular waveguide, but the shape of the circular waveguide it's be like a circle in shape. So the explanation of the circular waveguide is radar use rotating joints to link the horn antenna to the parabolic reflector, which is rotate for tractor. Just now I say the circular waveguide, it's a shape of like cylinder, like round in shape inside. So that's why it's like rotating for tracking. About the 10 gigahertz, the DE01 mode is suited for long distance waveguide transmission. So the circular waveguide is used for long distance waveguide transmission. Broadband communication over short and medium distance may replace share coaxial and microwave line. To cut down on attenuation loss, only work about a specific frequency range. Move on to next is elliptical waveguide. Elliptical waveguide is a precious formed from corrected high conductivity copper with a elliptical cross-section component. It is this corrugated walls structure that in turn gives the waveguide high crush strength, lighter weight, and then better flexibility for handling. This elliptical waveguide, it's a bit flexible to use it and lightweight too, and then it's a high crush strength too. Okay, more next is elliptical waveguide is often used in microwave antenna feeder system and offer benefit like low loss and single distortion. The elliptical waveguide also ensure VSWR performance. Elliptical waveguide is precious formed from corrugated high conductivity copper with the elliptical cross-section component. Just now I explained about it. On to next is double ridge waveguide. Double ridge waveguide. A rectangular waveguide with a ridge from the top and bottom wall is called a double ridge waveguide, which is there are two rectangular waveguide up and down, which is called double ridge waveguide. Ridge waveguide tends to have a lower impedance and wider bandwidth in their fundamental mode when compared to regular rectangle waveguide. So it's a bit big compared to rectangular waveguide. With a very wide monomode bandwidth, combo waveguide can be used as real transmission line to some extent. For an example, taps, filter, additional feeders in a very wide band that cannot be achieved with a rectangular waveguide. So it's a bit big and therefore more space to use it. More to next is single ridge waveguide. Single ridge waveguide. A single ridge waveguide is a rectangular waveguide with a single protruding ridge from the top or bottom wall in called single ridge waveguide. So it's explaining like there are rectangular waveguide with the top and bottom wall. It's called single ridge waveguide. Ridge waveguide tends to have a lower impedance and wider bandwidth. Just now I say about the ridge waveguide, it's low impedance and wider bandwidth in their fundamental mode when compared to the regular rectangular waveguide. Ridge waveguide is a fundamental mode. We have to understand about the ridge waveguide. Okay, move on to next is Praveen will explain about the uses of waveguide.
Okay, let's see the uses of waveguide. Okay, for the first is rectangular and circular. Okay, the waveguide is both rectangular and circular are widely used to connect the feeds of parabolic dishes to their electronics, which can be low noise receivers or power amplifiers or transmitters. Waveguides are used to measure the optical, acoustic, and elastic properties of materials and objects in scientific instruments. The waveguide can be placed in touch with specimen, as in medical ultrasonography, to ensure that the testing wave's power is conserved, or the specimen can be placed inside a waveguide, as in a dielectric constant measurement, to test smaller items with greater accuracy. Okay, let's see the next one. Okay, let's see the elliptical waveguide. Uses of elliptical waveguide. Okay, it's often used in microwave antenna feeder systems and offer benefits like low loss and signal distortion. The elliptical waveguide also ensures VSWR performance. Elliptical waveguide is precision formed from corrugated high conductivity copper with an elliptical cross-section component. Okay, for the next is rigged waveguides. Okay, it's tend to have a lower impedance and wider bandwidth in their fundamental mode when compared to regular rectangular waveguides. They also have a lower cutoff frequency and have low power handling capabilities. Okay, for the next one is single rate waveguides. Okay, there are two types of rate waveguides under rate waveguides. Okay, the first one is single rate waveguides, rectangular waveguides with a single protruding ridge from the top of the bottom wall is called a single rate waveguide. Okay, the second one is double rate waveguides. A rectangular waveguide with a ridge from the top and bottom wall is called a double rate waveguide. Okay, thank you.
Okay, that's all for our presentation. Before I end our session, I want to show our article and preview from Turnitin software. So here we have the article and with the content of abstract introduction, what is waveguide, type of waveguide, and the example question of waveguide, and application and uses of waveguide, besides advantage and disadvantage of waveguide, and the last one is reference. Okay, we done the article in the format of Arial font with 10 size with justify. Okay, then we done our reference in the APA format, and in the last one is our similarity. Whenever we check in Turnitin software, it will show 26% similarity, and the highest rate is 7% from Wikipedia. Okay, that's all from me. Thank you.
Thank you.